Welcome to the DIY Honda Garage channel. This presentation addresses the Diagnostic Trouble Code DTC P0502, which indicates a CVT speed sensor circuit open or short issue specifically for the Honda Civic model years 2011 to 2015. The CVT, or continuously variable transmission, relies on accurate speed data to function effectively. When a fault in the speed sensor circuit occurs, it can lead to transmission problems, affecting vehicle performance and safety. DTC P0502 is not triggered by mechanical issues within the transmission. Instead, it pertains to electrical malfunctions within the sensor circuit. Understanding the components involved and their functions is crucial for effective troubleshooting and repair, ensuring optimal vehicle operation. DTC P0502 specifically signifies an issue with the CVT speed sensor circuit, wherein the sensor may either be open or shorted. The CVT speed sensor is a critical component that monitors the rotational speed of the transmission and relays this information to the Powertrain Control Module, PCM. The sensor is typically located on the transmission casing, accessible after removing certain protective covers. If the signal is lost or faulty due to an open or shorted circuit, the PCM cannot accurately control the transmission's shifting and other functions, leading to performance issues. Therefore, recognizing that this error is tied to electrical circuitry rather than mechanical failure is essential in steering the diagnostic process effectively. The potential causes for DTC P0502 predominantly revolve around electrical circuit problems. These issues might stem from a faulty CVT speed sensor, which is critical for relaying transmission speed information. In some cases, the problem could be an outdated software version within the Powertrain Control Module, PCM, which can lead to misinterpretation of signal data. Damaged or corroded wiring connectors and open circuits between the sensor and PCM may also be responsible for interrupted signals. Understanding these causes is crucial for directing the troubleshooting steps effectively and efficiently to restore proper functionality. When DTC P0502 is present, several symptoms may manifest during vehicle operation. One of the most noticeable symptoms includes erratic transmission behavior, which may result in unusual shifts or delays in acceleration. You may also experience poor acceleration, as the transmission may struggle to engage properly without accurate speed input. Additionally, the check engine light will typically illuminate, indicating a fault within the vehicle's electrical system. In some cases, drivers may notice transmission slippage, which is a significant concern, as it can lead to further mechanical damage if not addressed promptly. Being aware of these symptoms helps in timely diagnosis and repair. The first step in troubleshooting DTC P0502 involves verifying the presence of the problem. Begin by turning the ignition switch to the on-to position without starting the engine, or using the engine start-stop button in an appropriate mode. Next, clear the Diagnostic Trouble Code using the Honda Diagnostic System, HDS. Once cleared, it is imperative to raise the vehicle on a lift, ensuring it is securely supported so that the wheels can rotate freely. Afterward, start the engine and disable the Vehicle Stability Assist (VSA) system by pressing the dedicated off button. It's crucial to run the vehicle in drive, D, at an engine speed of 1000 RPM or higher, and then release the accelerator without pressing it again for at least 4 seconds. If the wheels slow down and stop, proceed to check for any pending or confirmed DTCs with the HDS. Is DTC P0502 indicated? In the second step, the focus is on determining the possible failure area within the sensor circuit. First, Ensure the ignition switch is turned to the lock 0 position or off mode. Next, disconnect the CVT speed sensor's 3P connector to isolate it from the system. After disconnection, turn the ignition switch back to the on 2 position to power the electrical circuits. In this state, measure the voltage between test points 1 and 2. The test points correspond to the CVT speed sensor 3P connector, where test point 1 is number 1, yellow-blue, and test point 2 is the body ground. If you measure approximately 5 volts, it indicates the VCC2 line is operational, and you can then proceed to the next troubleshooting step. If not, further investigation is required. Step 3 requires checking for an open wire condition in the VCC2 line. Start by turning the ignition switch to the lock 0 position to ensure the system is powered down. Subsequently, use the HDS to jump the SCS line, which stands for the System Communications Sensing Line, ensuring accurate testing conditions. After this, disconnect the PCM, Powertrain Control Module, Connector B, which is a 51P connector. Now it's time to check for continuity between the designated test points. The CVT Speed Sensor 3P connector number 1, yellow-blue, and the corresponding PCM connector B number 29, yellow-blue. If continuity is confirmed, it indicates that the VCC2 wire is functioning correctly. In such a case, consider updating the PCM software or substituting with a known good unit. If DTC P0502 clears after an update or substitution, the troubleshooting process is complete. The fourth step is to perform an open wire check on the SG2 line. Begin by measuring the voltage between the test points, both of which are on the CVT Speed Sensor 3P connector. Ensure that the connector is still disconnected during this measurement, as this will yield accurate results. The test points in question are CVT Speed Sensor 3P number 1, yellow-blue, and number 2, green-yellow. Record the voltage reading. If you find approximately 5 volts, it confirms that the SG2 wire is intact, allowing you to proceed to the next troubleshooting step. However, if the voltage is absent, there may be an open in the SG2 wire between the sensor and the PCM, necessitating repairs to restore proper continuity. The fifth step focuses on checking for shorts in the VEDD line, which is critical for the sensor's functioning. Begin by turning the ignition switch to the lock 0 position to ensure the system is off. Using the HDS again, jump the SCS line to initiate precise measurements. Next, disconnect the PCM connector B, ensuring that this important component is isolated during testing. Then, conduct a continuity check between the CVT Speed Sensor 3P connector number 3, white T red, and body ground, marking the test points carefully. If continuity is present, it indicates that a short to ground exists in the VEDD wire, which should be repaired before further testing. If there is no continuity, the wire is likely not shorted, allowing you to move on to the next procedural step. The final troubleshooting step includes checking for an open wire condition in the VEL-DD line. Ensure the ignition switch is in lock or off mode, keeping the electrical system powered down during the check. Measure continuity between the corresponding test points. The CVT Speed Sensor 3P connector number 3, red mode, and the PCM connector B, number 8, also red mode. If continuity is confirmed, then the VEL-DD wire is functioning as expected, leading to the recommendation of replacing the CVT speed sensor itself to resolve DTC P0502. If continuity is not found, it indicates an open wire condition that must be repaired between the CVT speed sensor and the PCM before rechecking the system's function. After completing all necessary repairs for DTC P0502, it's vital to perform final verification to ensure the repairs were successful. Begin with an inspection to confirm that all connections are secure and no new Diagnostic Trouble Codes, DTCs, have appeared in the system. Using the Honda Diagnostic System, HDS, check the system for any residual or new fault codes that could indicate ongoing problems. Once confirmed, it is recommended to conduct a test drive of the vehicle under varied conditions to monitor performance and ensure that all systems, such as the CVT, operate smoothly. Finally, ensure that all electronic systems remain operational without triggering any warning lights. This verification process is essential to establish that the vehicle is restored to its original functional state. Preventive maintenance plays a crucial role in avoiding the reoccurrence of issues such as DTC P0502 in the future. Regular inspections of the vehicle's wiring, especially within the CVT sensor circuit, should be prioritized to catch any wear and tear or corrosion before they lead to failures. Furthermore, keeping the powertrain control module (PCM) software updated ensures that the vehicle's systems function optimally, adapting to any performance enhancements or fixes issued by Honda. Monitoring the performance of the speed sensor regularly can also predict potential issues before they become critical. Additionally, maintaining clean and secure connectors helps to prevent moisture and corrosion buildup, which can lead to electrical faults. Together, these practices will aid in sustaining the vehicle's overall performance and reliability. In conclusion, understanding DTC P0502, which reports an electrical fault in the CVT speed sensor circuit, is essential for effective vehicle repair. This code reflects issues within the sensor's circuitry rather than mechanical transmission failures, emphasizing the importance of electrical diagnostics during troubleshooting. Each step in the troubleshooting process targets specific components and connections, providing a systematic approach to identifying and rectifying the problem. Adopting preventive maintenance practices can significantly enhance vehicle reliability and performance, reducing the risk of similar faults emerging in the future. By remaining vigilant and proactive, vehicle owners can ensure their Honda Civics continue to operate smoothly and safely. Please like and subscribe to the channel. See you next time.